So welcome students. So in this question you're given a variable plane 2 lambda plus 1 times x plus 3 minus lambda times y plus z is equal to 4. You're asked to find the line through which every member of this family passes through. That is, so if you analyze this, this is a family of planes. That is, so 2 lambda x plus 3y minus lambda y plus z is equal to 4. So if you combine the terms, it will be something like this: lambda times 2x minus y plus x plus 3y plus z minus 4 is equal to 0. So there are 2 terms corresponding to lambda and there are 4 terms without lambda. So this is of the form plane 1 plus lambda times plane 2 is equal to 0. So what does this family represent if I change lambda, if lambda is the parameter? So p1 plus lambda p2 is equal to 0 represents a plane passing through the intersection of these 2 planes. So this family represents a family of planes. Family of planes through the intersection of P1 and P2. So you have plane 1 and plane 2. So now each member of this family will pass through the intersection of these 2 planes. That is, if you take this as my plane 1 and this as my plane 2. So this is the line of intersection of these 2 planes. So all the members of this family contains this line. So this will be the line which is asked of you. So this is the line which is contained in all these planes. So you just need to find the intersection line of these 2 planes. So how do you find the intersection line? So to find that, you just need to understand one logic, which is that this line is normal to this plane as well as this line is present in this plane as well as this plane. That means this line is normal to the normal of first plane. And this line is also normal to the normal of second line. So the drs of this line should be perpendicular to the drs of n1 as well as n2. So now if you take p1, what are the drs of the normal? The drs of normal are nothing but the coefficients of x, y, z, that is 1, 3, 1. So what are the drs of p2? Drs of p2 are 2, minus 1, 0. So drs of p1 are this, drs of p2 are this. Now what are the drs of a line which is perpendicular to both of this? That is nothing but p1 cross p2. So the dr should be along p1 cross p2. So p1 cross p2, p1 bar cross p2 bar is nothing but I, j, k, 1, 3, 1, 2, minus 1, 0. That is equal to I times 1 minus j times minus 2 plus k times minus 1 minus 6 is minus 7. That is equal to I plus 2j minus 7. That means this line is in the direction of I plus 2j minus 7. So that means this line will be of the form x minus something is equal to y minus something is equal to z minus something divided by 1, 2 and minus 7. It should be of this form. And this numbers that you get is any point on this line. You have a lot of points on this line. You can use any point on this line. So we can just find a sample point on this line. So what is a sample point? You just need to put x is equal to 0, y is equal to 0. So if you put x is equal to 0, y is equal to 0 in this plane, so this is satisfying this first plane. And if you put x is equal to 0, y is equal to 0, you get z is equal to 4. So what is a point which satisfies both these planes? 0, 0, 4. So you can put 0 here, 0 here, 4 here. So this is the line which passes through, which is present in all these planes. So but this 0, 0, 4 is not unique. You can find any point on this plane. That means if you put x is equal to 1, y is equal to. So if you put x is equal to 1. So on this plane, if x is equal to 1, y should be equal to 2. And if x is equal to 1, y is equal to 2. So 1 plus 6 minus 4, that is 3. So z is equal to minus 3. So you can use this point also. So you have to check which point is used in the plane, and you have to check whether that point satisfies both these planes or not. So 1, 2, minus 7, you have only third option, and the point used in the third option is 0, 0, 4, which is also okay. 0, 0, 4 satisfies P1 as well as P2. That means that is in the intersection of P1 and P2. So option C is the right answer to this question. Thank you.